Hello, everyone, and welcome to our latest online event here at the University of California, Merced. My name is Ricky Hill. I am the e-recruiter here at UC Merced. It is such a pleasure to be with you. A big welcome to you tonight as another one of our online events, part of our Discover UC Merced series. Tonight, we will be talking about electrical engineering. Before we get started, let me give you a couple of quick tips. If you need to adjust your audio settings, you can do that in the lower left corner of your screen. If you would like to adjust the size of your window, click on View options in the upper portion of your screen. Lastly, and most importantly, like all of our virtual events here, we are here to get to all of your important questions. Please take full advantage of the Q&A button located on your screen. You can send us those questions throughout the presentation. We will get to those either behind the scenes where we are fully staffed with content experts or during a live question and answer session at the end of this live event. Once again, my name is Ricky Hill. It is a great honor to be with you tonight as we speak about electrical engineering. As we do get started, let's go over a quick program overview. Again, a big welcome to you for joining us tonight. Next, we will be going into a portion to learn about electrical engineering at UC Merced. Next, you will hear from our faculty and our students here at UC Merced. And lastly, as I mentioned, use that Q&A button at the bottom of your screen. You can send us those questions. We will get to those throughout, as well as at the end during a live question and answer session. Once again, my name is Ricky Hill. I'm the e-recruiter here. We're so excited to have you. At this time, it is my great honor and privilege to hand things over to Professor Kurtz.
Hi, it's also my privilege to be with you. This is a really, really special event. We've spent the last couple of years talking about how we could create an electrical engineering program here at UC Merced. I'm listed on this slide as being a professor and graduate chair of MBSE, and you probably wonder what MBSE is. That's my current role, but starting this coming fall, I will get to lead the electrical engineering program. And on the next slide, we are looking at why electrical engineering. So have you ever thought about how important electricity is? What are things that electricity enables us to do? If you think about it, it's almost everything. I bet each of you has at one point or another been in a situation where the power went off. And I don't know how you are, but when the power goes off, I can't think about pretending that maybe I'm out in a campground someplace and just kind of camping. But I usually just feel kind of disoriented, like, what can I do? Like I turn the light switch and nothing happens, or I open the refrigerator and it's dark, or all kinds of things are like, this is really strange. Electricity is really, really important to what we have nowadays. You know, more than 100 years ago, most people didn't have electricity, but now we count on it for most everything. So we'll return to the why question after we've gone through some more of the basics about the new program that we're offering. So on the next slide, we asked the question about when to apply for electrical engineering at UC Merced. And the answer to that is you can apply right now. It's really exciting that this is our first time to be able to offer. This is our very first webinar and our very first opportunity to invite students to apply. So we're really excited about that. Hopefully you can apply to join us in fall of 2023 as a first-year student. Now, if you're a transfer student, we're not really ready to accept you yet. So we'll be accepting transfer students in the fall of 2025. And the first electrical engineering graduating class will be in spring of 2027. So something to keep in mind there is that as we begin to introduce the curriculum each year, we'll be adding new classes. So if you are a second year in 2025 or 2023 and wanting to graduate in 2026, we won't have offered the classes yet. And similarly, if you were a transfer student, we wouldn't be able to offer all the classes yet. So we'll need to stick to this timeline. On the other hand, if you're not quite sure about what you want to do, on the right, you see an advising tip there. There are a lot of students, I know that when I came into college, I was about your age, and I was like, I'm not sure what I want to do. And I actually was thinking about being a major in math and Spanish when I was a first-year student. But then I got into it and I decided, no, this isn't the right thing for me. So then I ended up switching. So if any of you are like me and want to switch majors after you get here, that is perfectly possible. One of the key things is that most of the engineering majors start with calculus and other standard courses in the first year. And so if you take the courses for electrical engineering, you would have the possibility to switch to another major at the end of the first year. Or if you started in a different major and then you decided you wanted to switch into electrical engineering, you could do that equally easily. A key thing is that we're offering a class in the very first semester, we'll call it EE001, which will encourage you to take. And if you're not sure if you want to take electrical engineering or some other engineering type, you can always change directions after the first semester. But taking some of the other engineering programs also offer that an introductory class, and that can be a really good way to figure out which major is right for you. So if you use the QR code on the left there, you can get started applying in an application right away. This is the Exploring EE001 that I just mentioned. The things that you'll get from this course is an introduction to electrical engineering. You'll meet with some electrical engineers. You get to engage with an electrical engineering project, and it should help you decide if electrical engineering is the right fit for you. And again, the advising tip, students who are undecided but considering electrical engineering are encouraged to enroll. And then after it's all done, you can decide whether it's the right program for you or not. We think that hands-on projects are really very important. You can work on math problems. Probably many of you in high school right now are taking calculus classes, and you have math problems that you're given. And it's like, okay, I've worked this math problem. There's an algebra problem. I've worked that problem. But what does it relate to the real world? So somehow or other, doing things with your hands and having something at the end of the time that you can show for what you've done is really useful. So we'd like to have you doing projects that you'll find fun and useful. And I'd like you to think about what are the examples of projects that you'd be interested in doing. And if you could begin to share those in the chat. We'd like to gather your input. I'm going to come back a little bit later and give you a couple of examples of things that we might do. We also have time during our live Q&A if you want to make suggestions to us. Here are some examples of things you can do with electrical engineering. These 3 slides all happen to be of things from my personal research. In the next 2 slides after this one, I'll introduce a couple other professors. But here we have, in the left, we have a picture of some of us next to a solar field that's near the university. And we had a project out there where we were looking at how fast the solar panels get dirty. You've probably looked at solar panels on people's roofs and wondered sometimes, if they're getting dirty, do they still generate electricity? So we were studying the soiling rate there. In the lower picture, we have a test place where we measure the performance of the solar panels. And you see 2 large solar panels there, but you can also, if you look closely, you'll see a bunch of little ones. And those little ones are new technologies that a company is paying us to test to see if they will make good products to deploy. And so it's really fun to see the latest state-of-the-art technologies and be able to study that. In the upper right, we have a picture of a field trip that we made where we went up to look at a system where they put the solar panels floating on the water. Behind us there, you can see the water with the reservoir. And one of the things you can do is on a reservoir, you can cover it over with the solar panels. And then what you find is that the weeds and things don't grow in it as much. And then the solar panels are very conveniently located there. So we had fun driving and getting to see that system. On the next slide, then, I get to introduce to you Professor Chen, who is also an electrical engineer he's also a mechanical engineer, actually, but he's doing both electrical engineering, mechanical engineering, computer science, and he's going to tell you a little bit about his research. So I pass it off to Professor Chen.
Thank you, Sarah. So my lab also in Castle is doing something called mechatronics. Electronics is a combination of 4 different areas. One is mechanical engineering, another one is electronics, another one is control systems, and another one is computer systems. So you can see this 3 things. You have computer, mechanical, you have controls in there. So drones are one of the mechatronic systems. The ground mobile robots also are mechatronic systems. So I teach a course on the mechatronics. So the picture showing here is to use a drone equipped with a multispectral camera to fly over and to check the water stress or the vineyard, the health status to manage the water. So this is called precision agriculture, where we use the resources like water, like fertilizers, like pesticides, whenever it's needed. So it's called SSM, or site-specific management. To do that, we need to have a sensor in a large scale. So people may think about using satellites, but you know that in the satellites, the resolution of the spatial resolution is 30 meters. You know, you cannot use it for individual tree level care of the agriculture, okay? So we needed the drones. I call it personal remote sensing, just like a personal computer, remember? So with this personal remote sensing capability, there are endless possibilities here. And you can see that the electrical engineering is a very, very important part of that. At this point, I want to tell you that I feel very excited today because we are, and together will be part of the history. So this is the ever first EE program. We show the world. We try to recruit strong students to our program. So if you want to see some of the videos, and you can do the QR, and you can go to some of the clips. We entertain many of our undergraduate students doing research in our lab in the summer. And some of them actually get paid to have fun in our lab, going into the field. We call it field mission. So I wish to emphasize that the EE program will leverage our strong undergraduate research involvement. So many of you will have opportunity to work in the professor's laboratory to gain the research experience, and will be better prepared than in other campuses, okay? You have a better attention from professors to prepare you for your next stage of your career, either go into graduate school or go to the job market. So I pause here, Sarah.
All right, thank you, Yang Quan. So my name is Ricardo Castro. I'm an assistant professor in the mechanical engineering department, like Yang Quan Shen, and my background is also in electrical engineering. And I always liked electric circuits since I was a young boy. I like to understand more about how electronics work inside computers, inside TVs, and other appliances. And so this curiosity led me to join an electrical engineering degree. And when I was in college, I found that cars, which is something that I love, they need a lot of electronics. And that combination of electronics and cars stimulated me to start working with electric vehicles. And so over the last 15 years, I've been doing research and development with different types of technologies, motor controllers, power converters that are then included inside an electric vehicle. I also find that electric vehicles offer many advantages in comparison with internal combustion engine cars. For instance, they don't have emissions locally. They don't generate CO2 gas. They accelerate way faster than regular cars. In fact, if you go to YouTube, it's really fun to see how a Tesla and all the electric vehicles, they out-accelerate other cars from standstill. They also have less maintenance, so you don't need to change the oil. They generate less noise. And some of these advantages can be seen in a few of my videos that I have in my website. I think you can follow the QR code to know more. about the advantages of EVs, and also to see some of the EV prototypes that I built throughout my career. And I also learned in the last years that electrical engineering is a key knowledge, is a key course for you to help us build and design an electric vehicle. And I hope you can join us here at UC Merced, join our EE program, and help us develop clean cars in the future. And I think I can pass to the next slide. Yeah, thank you.
All right. Good evening, everyone. I'm Thomas Kellogg. I'm a third-year transfer student here at UC Merced and a student of Dr. Castro's. I'm going into computer science, but this is still a topic that is very interesting to me, electrical engineering. So I've been invited to present a few slides on the subject. As a student, I can speak directly on what the student experience here is like. There's a lot of resources available to us. One example is the Vanguard Engineering Society, which is kind of an umbrella organization for all the STEM organizations on campus, student organizations. It includes the American Institute of Aeronautics and Astronautics, the American Society of Mechanical Engineers, the Biomedical Engineering Society, National Society of Black Engineers, and the list goes on and on. Soon, hopefully, it will have the UC Merced IEEE student branch, which is what I'm currently working on setting up. The IEEE is the world's largest professional organization. They focus primarily on electronics and electrical systems, but because everything has circuits, this means that they overlap with a lot of fields, including medical and biomedical, computer sciences, information technologies, engineering, math, physical sciences. So it's a very diverse field with a lot of, lots of opportunities. Among those opportunities, upcoming October 22nd, we have our first hackathon that we'll be participating in. It's a computer science competition that runs for 24 hours, starts at midnight and ends on midnight. So be solving computer science problems. So for those of you who are interested in that field, such as myself, that's something we're doing. On November 1st through the 4th, we have the 19th annual IEEE Vehicle Power and Propulsion Conference, which is Dr. Castro's work, working with electric vehicles. And then because of all the different opportunities, or because of all of the different STEM opportunities, we're working with the Solar Energy Association, Association for Computing Machinery, and Robotics Society student organizations for interdisciplinary projects, because again, circuits are in everything. I'll hand it off to you, Dr. Kurtz.
Why is electrical engineering important? If you think about it, you've got a smartphone in your pocket. You've got a smart thermostat on the wall. How do you make those things be smart? Part of it is the programming that you need to do, the software development, but a lot of it is making the circuits work. As the world is moving to replace fossil fuels with renewable energy, we're having electricity replace the fuel. So if you think about it, there are a lot of things in your life, whether it's your car that you put the gasoline in, maybe you have a lawnmower or something that you put gasoline in. We're looking at replacing a lot of that with electricity. It turns out that electricity is typically more efficient. I don't know if you've thought about it, but in your car that you drive down the road, there's a radiator that gets hot. And the reason you have the radiator in front of your car is to be able to dump all the extra heat. That's wasted energy. If you get an electric vehicle, it turns out that you don't need to have that radiator because it doesn't have that much heat that gets dumped. If you think about it, if an electrical gadget stops working, wouldn't you like to know how to fix it? Have you ever had something in your house stop working and you thought, I'd like to have that working, but you don't know how to fix it? If you become an electrical engineer, then you learn the skills to be able to do that. So when an electrical gadget does something useful, but not quite what you'd like it to do, maybe you'd like to be able to improve it. Or maybe you have a vision. I remember my son went to college and they had a problem that they couldn't figure out if there was somebody in the bathroom. And so they rigged up a little gizmo that if somebody closed the door, it would turn on a light outside, and then they could figure out whether the bathroom was available or not. So you can come up with ideas of things like, I'd like to see it do this, and then you can go and do it. And that's why we wanted, on the next slide, we wanted to ask you about what kinds of projects, what excites you about electrical engineering. This is a brand new program, and today's students are different than the students were when I was your age. We'd really like to know what kinds of things you're interested in. And so, for example, I've heard of a group that went and said, okay, if I'm going to go on vacation for a while, and I've got a plant here, and I don't want it to die while I'm gone, so can I put together a little system that will measure the amount of water and then water the plant whenever it needs it while I'm gone, and then when I get back, it's in good shape? So that's an example of a little project that you could imagine doing as an electrical engineer. And I wonder if any of you right now can type in like ideas you have of things that you think would be really cool. Like if I could do this, like if I could make lights flash, or if I could do this, that would be really fun. Do you have any ideas that you can share with us right now? So you can enter them. I think it's mainly you need to put them in the Q&A, or it may be possible that you can do the chat. I'm not sure about that.
Yes, thank you so much, Professor Kurtz. So to our audience, please go ahead and click on that chat button, and that little box will pop up for you where we've been sending you information. Now is your chance that you can actually type to us. So as the prompt was, go ahead and feel free to offer us your feedback, and we can discuss that now. Yes, and we actually do have one bit of feedback here that one of our listeners has written in, so I'll go ahead and read that to you. So if I could have doors and drawers automatically open for me when I reach for it in case I'm carrying a handful of stuff.
That's a great idea. I wonder how we would do that. Do you think you've seen that there are some kinds of doors already that do that kind of thing, right? So that's a good idea. We should think about how we would design that so that we could just touch it and have it open.
Looks like we have one more. So the next one is, can EM make my Wi-Fi range bigger?
Well, so certainly there can be ways to make your Wi-Fi range bigger or smaller. That's a good one for us to talk about. And there are new technologies about how the communications, how the Wi-Fi actually works. And so learning about some of that is part of what we might do with electrical engineering. I see one person who says, I'm really looking forward to the new curriculum. Great. I look forward to meeting you in person.
Absolutely. And then we do have one more in our chat there. If you can see that, Professor Kurtz, it says, have there been projects in the works in case the power grid were to go down for Californians like it did in Texas?
Well, that is a fascinating question. Some of you may have heard that in the recent heat wave, we almost ran out of electricity. And what they did was to say, okay, the next thing we have to do is rolling blackouts. And I don't know if any of you have ever been in a rolling blackout, but I remember when they did that. I was in Denver like 10 years ago when they did it. And they would take a whole neighborhood and turn off the electricity for an hour. And then they would take another neighborhood. And what they did this time was they sent a message to everybody on their cell phones and said, we're going to have to do rolling blackouts now. And said, could you please help us by turning off the electricity or turning off whatever you're using of electricity? And they saw the demand for electricity to drop. All those people went over and turned off something, and everybody turned off a little something. They've found that the demand dropped. But in the meantime, the main thing they're putting in now is a lot of batteries. And they're also installing more electricity generating capability. But the big thing right now they're focused on is electricity, is the batteries to be able to generate the electricity after the sun sets. And I see one who's interested in working in cars. So Professor DeCastro will be very pleased to have you working in his lab. And I see solar powered rollerblades. That sounds like fun. And a potential idea, boy, we're going to have to save this chat. I hope one of you will be able to write it down. A potential idea could be a method to hack common household items and control them from a phone. So one of the student clubs here had a project where they took a solar panel that was supposed to track like this, and then they made it track. They hacked into it and got control of it and made it move in the wrong direction. So that's actually a really fun project to do, to hack into something. Yes, they're awesome ideas. Some cars can already open autonomously at the lift gate when a foot is detected under the rear bumper. That is fun. Yes, that's the sort of thing that we could do as an electrical engineer. Can electrical engineering be used to increase traditional combustion engines more efficient with hybrid technologies? Definitely, that's what a Prius does, right? Batteries that don't expire. We need to make batteries that last longer. That's definitely in the plan. That's one of the things that they're working on to be able to improve the electricity reliability in California. Is there a stress system? It's like a stress meter that measures the resistance of the skin or detect what level of stress you have. I heard about it, but wasn't sure if electrical engineers can develop that. Yes, so it would definitely be an electrical engineer who needs to be able to detect it and then give you a readout to tell you what the answer was. Then is that what Internet of Things is? So the Internet of Things is really exciting because you can put a little sensor most anywhere and connect it to the internet, and then you can connect it anywhere. So if you put like a little camera and you say, I want to see if somebody's coming to my front door, but I'm actually not at home, then you put the camera by your front door and you connect it to the internet. And then wherever you are, you pull out your phone and connect to that camera and you can see who's walking up to your front door. It would be a great thing to have on Halloween for a trick or treat night, I think, especially if somebody's going to do a trick on you. So there are definitely a lot. The Internet of Things is a really important one. Solar panel on the phone. Yes, so people have looked at putting, you could take the back of your phone and put a solar panel back there, and then when you need to charge it, you can put it in the sun instead of having to plug it in. That could be really useful. Or you can have a solar panel and then just plug your phone into the solar panel. All of the roofs of new houses should be solar panels, and every house would generate a small amount of electricity. The fact is that in general, a new house, if you covered the roof with it, the new house can generate enough electricity to run the whole house often. Another potential idea is using chip cards inside the human body to replace cards such as debit cards, but there'd be plenty of flaws to that idea though. Well, people are definitely talking about that. I'm not sure it would be a project we would do as you're a freshman here, but we could talk about how it could work, because that could be really handy, or some people might find it an invasion of their privacy, but it could be really handy if you didn't have to like carry your card in your wallet, if you just could like stick your hand out and then they would know. It's almost like the same if you just like have your fingerprint, and then you can read the fingerprint, then people know who you are without you having to pull out your identification. I should give the other professors a little bit of chance. Ricardo or Yang Quan, if you want to respond to any of these, please feel free to jump in.
Okay, so I saw the last question was rocket. Of course, now rocket, you need electrical engineering to get it launched. Actually, in Castle, we have a student club. They do a certified rocket launching for the mile-long competition, actually. So who can exactly launch the rocket and land at the 1 mile mark. We have a very active team in here. If you play the rocket, you want to lead this club, be part of it. So this is a great place you can play the rockets. We need electrical engineering. You know that the rocket is actually under control. Actually, it's a missile, actually, in certain sense. Great. So what was the other question? I minimized my chat box, cannot see very well.
So there was one talking about 3-phase induction motor for robotics and microcontroller.
Oh, yes. But right now, we want to do a lot of high efficient motors like brushless DC motors. So the external characteristics looks like a DC motor is much easier to control, but internally there's very complicated three-phase switching inside. But you don't have to know the details inside of the motor. You only know that it's a brushless DC motor like we use in a drone. Yes, I'm glad that you know three-phase motors. So great. Anything else?
Could you also answer the one about these ideas cross both electrical engineering and mechanical engineering? What are the key differences between the two engineering fields? Or maybe you can talk how they kind of—
Mechanical engineering?
He says mechanical engineering and electrical engineering. What are the key differences? Or maybe you want to talk about mechatronics, where you can bring the two together.
Okay. So first of all, I think look towards the future, the differences is getting more and more blur. You cannot really draw a line, because today the mechanic system are getting smarter and smarter than ever before, because you put in more and more microprocessors, computer controls into it, make it more flexible, reconfigurable, and so on and so forth. The same thing is true that you have electrical system, electronic system, you have a mechanical system as a substrate. So just think about robots, okay? You can't, it's hard to imagine that you only know electrical engineering, you can make a robots nicely. You should also know mechanical engineering. So those are hand in hand. So we should not say, oh, I don't want to touch mechanical engineering. So it's more and more fused together right now.
So it's good to know both of them. But if
Yes.
you try to do both and get a major in both, it's a lot of classes. In electrical engineering, you'll learn more about how circuits work and how signals go through a circuit, how communications work, how motors work, things like that. In mechanical engineering, you may learn more about fluid dynamics, so how like water flows through pipes, and the strength of materials, if you can bend them. There are lots and lots of different things that you'll learn though. Okay, so here's a good question for me. Do you think that one day solar panel technology will get good enough to fully charge a car about 300 miles during the day? I know there is one new electric car company named Fisker, who has developed a solar roof for the car. However, the panels on the car can't charge a lot during the day. This car is being delivered to customers next month. Yes, so I could work with you on doing the calculations. You can get from a square meter, you can get about 200 watts. If we get the solar panels to be really good, could be about 300 watts per square meter. And the thing is that you can drive maybe about 4 kilometers on a kilowatt hour. So if you look through it, it's actually really difficult to get a car to charge just from the solar panels on the car to go 300 miles. However, you can look at putting, say, a carport, and then you can park in the shade of the solar panels. And if you charge from the solar panels that would go, say that you parked under in a parking lot, there it can be possible to get enough electricity to drive a car a much further distance. I see another project idea is gravity-based renewable energy storage. And you know that there are people who are designing systems where they're lifting like blocks. They might take like used concrete to make it into a heavy block, and then they lift it. Or there are other people who are looking at taking water and mixing things in the water so that it's extra heavy, so then you don't need as much water to go up and down. That's another example of how mechanical engineering and electrical engineering come together to do hydropowered. And there was one suggestion here of a hydropowered car. I have to understand how that would work. Would you have like a water tower and then the water falls down and you use that to generate to go? Efficient hydropowered cars. I'm curious how that works.
Maybe it's a hydrogen car.
Oh, maybe a hydrogen powered car. Yes, so that would be like a fuel cell vehicle. That would make a lot of sense. Or maybe
there's a question regarding EE and CS.
Okay. You want to answer that one?
I can say a few things about this. But UECS, you can see that UC Berkeley, also in our UC Merced, we have EECS combined program is at the graduate level. For undergraduate level, I believe that EE and CS should separate. You have a different emphasis. But in a graduate level, it's usually combined because the research you do electrical engineering, you do make a robot move. But next question is how they can move smartly, intelligently, autonomously, and so on and so forth. So then you need to have a brain for those robots. That brain is like a high level programming, artificial intelligence, machine learning, reinforcement learning, and all those advanced algorithms could be injected into the electrical engineering system. So then would like to say electrical engineering and computer engineering, they also hand in hand at certain stage. But undergraduate training, they probably should be a little bit separate. On the other hand, the computer science is more on the algorithm and software side, but electrical engineering is perhaps more on the power and energy and information side.
We've got a bunch of questions here that I think we can be looking at answering, and maybe Ricky can help us to work through that. Would you like to do that at this point, Ricky?
I would love to. Thank you so much. What a fantastic conversation we just had. I am very impressed with all of those great comments coming in. And of course, the great comments coming back from our faculty. This is making me even excited about this brand new program. Let's go ahead and dive into our first question. Is civil engineering completely different to any of these being discussed, or are there some connections?
Civil engineering, like we've just been talking about with mechanical engineering, has some overlap. A key thing about civil engineering is, if you think about it, we need civil engineering to like build our bridges and make the infrastructure in the world around us. But there are many aspects of it now that also use electricity, and then the electrical engineers need to work with the civil engineers. We do have a new civil engineering program here. It's only a couple years old. And so if you're interested in civil engineering, you should look into that program. But we may eventually, I hope that we can make it so that you could say be a civil engineer with a major and get a minor in electrical engineering, or the other way around, that you might be able to get a major in electrical engineering with a minor in civil, so that you would be able to use those together.
Fantastic. Thank you so much. Our next question. What kind of process do electrical engineers go through to evaluate the efficiency or viability of different green energy projects?
Well, that's something that we might take a whole class to go on. But almost anything that you do can be met with green energy if you work hard enough. And so what you're going to want to do, first of all, you want to electrify it. And then next, you want to find the source of the electricity and to find a way to make it be reliable. If David Yang, who asked that question, wants to connect with me later, because renewable energy is kind of my area of expertise, I'd love to connect with you about that.
Wonderful. All right, the next question that we have here. In order to go to electrical engineering, what subjects are required to be completed with an A in high school?
Is that a good question for Carla, maybe?
I think so. Carla?
Hi, everybody. You just have to meet the admissions criteria. You don't have to get an A in a particular course. You just have to meet the general admissions criteria to UC Merced, and you can apply directly into the program.
Great. Thank you so much, Carla. And the next question, what are the benefits of taking this major?
Well, you learn how electricity works. And I talked through some of them earlier. If something breaks, you have an idea of how to fix it. If you want to do something new, you may be able to design it. But of course, the most important thing is that you should be able to get a job. I heard there was a lecture given by someone from the Department of Energy a year or so ago, and a student asked the question and said, what advice would you give students today? And he said, we're looking at electrification. That is, if you take something that today works on, say, gasoline, and we're electrifying things, we're going to need a lot more electrical engineers. So he said, you know, you should go into electrical engineering. That was his advice to those students.
Wonderful. And can we talk a little bit about how long this program goes?
The plan is that it would be a 4-year program. So if you come in and are ready to go straight into calculus, you should be able to complete the program in 4 years. If there's some courses that you didn't complete in your high school, then you may want to take a class or two, and it may take a little bit longer, but we hope that you can complete it in 4 years. And I don't know if Carla wants to add anything to that.
No, I think that that's accurate. It's a 4-year graduation plan, and this program is allowing for a little bit of flexibility, so it will be a really good program for everybody.
Wonderful. And a little bit along those same lines, how many courses are there in electrical engineering? So a little bit more information specific to that.
So we will have about a dozen courses, and so in the first 2 years, you take mainly more the standard courses of calculus and physics and a little chemistry. And then it's more in the advanced years that you get into more specifically the electrical engineering courses. And if you're interested in learning about them, you can contact me directly. We don't have all of them created and listed in the catalog yet. We'll be creating them as the time goes by. But there's pretty standard courses that you can look up on most any UC campus that has an electrical engineering degree. We'll be offering courses that are very similar to those.
Wonderful. Now, this question, someone is saying they're sending in just out of curiosity. In your opinion, or any of the other professors' opinion who are on tonight with us, what would you say is more fun to learn and how to do? Would that be electrical engineering or computer science engineering?
Okay, well, I think that depends a lot on what you're interested in. So if you like writing software, if you like just sitting at a computer and typing in and making your program work and finding all the bugs in it and figuring out how you structure everything to get a project done, then computer science is probably the right thing for you. If you like actually like putting things together and making things work, you can make circuits, you can get a circuit that makes things go. If you like making things happen and like to do things with your hands more, you still have some programming and things to do like that in electrical engineering. But I think it's maybe a little bit more hands-on and physical. But I'm really curious if either of the other professors on here would like to add anything to that, or if they agree with that.
I fully agree with you, Sarah. So from my experience, electrical engineers, usually they build hardware, they build stuff. And then in computer science, you are more behind the computer writing code. And that depends a bit on what is your preference on the long run. What kind of activity do you like to do on the long run? For me personally, I like to build systems. And so I really like mechanical and electrical engineering.
But it's really useful if you're an electrical engineer and you put something together. Nowadays, almost every circuit turns into some sort of a smart circuit, and you need to interface it with the computer to be able to control it. So someone who can do a little bit of both, a little bit of programming, but understands the circuits so they can put them together is really valuable today. So hopefully we can find a way that you could do a little bit of both of them.
Wonderful. Our next comment or question here. I would like to know more about computer engineering and what the relation is with electrical engineering.
So
Sure.
you need both. You need a little bit of both. The computer is more the software and the electrical engineering is more the hardware, but we need to work with them together in order to get things to work well.
Perfect. All right, the next question. What if you've already taken Calculus AB and BC along with Statistics AP? Would the courses be only circuit related?
No, so the program is actually, it'll allow you to take other courses and before you end up just taking your electrical engineering specific courses. You're also required to do your general education courses. So your first year, it depends on what your scores are for the AB, BC, even the sub of the AB and the BC. So it really depends on your scores, your Bobcat advising, center academic advisor will be able to help you choose courses that will lead towards you moving onward with the program. It just kind of means that you'll start a little bit earlier. You still have your physics, you still have other classes that you have to take. So no worries, there are courses that you'll take your first year that are still related towards the degree. I would just say that all of our courses are offered at UC Merced. There's some courses that you could take at community colleges, like your math and your physics and things like that. You could take it, but know that once you enter here at UC Merced, you can complete the degree within 4 years. And you can always utilize summers for that. But as an academic advisor, I'm going to suggest that you also consider what else you're going to do with your summers to advance your degree and work on these wonderful projects that you guys all have been sharing and that Sarah and the faculty have been talking about.
Great, thank you so much for that. The next question, which major would you say is more challenging? Electrical engineering, computer science engineering? So a moment ago, we asked which one was more fun, but now we're flipping the script a bit and saying which one's more challenging?
Well, I think this comes back to what you're good at and what you feel comfortable with. So there's some people who love to get up on a stage and act and, you know, do all kinds of, maybe be a comedian or whatever. That would be really difficult for me. But for some people, that's just kind of like the way they live. So if you find that with computer science, if you find you're really good at logic, then computer science is all about figuring out, if I do this, then what will that drive? And how do I put it together in such a way that I can step by step work through a process and get the computer to execute the task that I'm looking at to do. If you like to sit and working at computers, then, and if you're good at finding the problems in your code, then that's a really good thing. If you like working with your hands more and you can see how the logic of a computer, of a circuit lays out, then I think you'll find that the electrical engineering is easier for you. So, but the bottom line is you can sign up for both, sign up for electrical engineering to begin with. And then if you decide you want to switch into computer science, I think that can work. Tell me, Carla, if I'm giving them bad advice. Maybe they're better off going for computer science first. You can check out both of them and then make a decision a year in, as long as you make it within, I think, the first year, which between the two.
You'll have about a year and a half to really make the distinction, especially if some of the courses overlap, especially the math and the physics, things like that. You honestly can apply to either program, and you will be able to change majors as soon as you meet the change of major criteria for the new major. So doable for you to switch between majors. This campus is really great about that. So choose one, start there, and then the first year you can talk to your Bobcat academic advisor and let them know, hey, I want to now do this other major, and they will help you out.
Wonderful. Thank you so much for that. We are getting closer to wrapping up this fantastic event. We've had so much fun tonight, but we do have time for a few more questions. What is the overlap between EE courses and other engineering courses?
So we start in the overlap mainly in the first couple of years where you're taking more calculus and physics, chemistry, and there are also GE, general education classes, where you can choose between a lot of things that then would count no matter what major you would end up in. The overlap, I'm not sure the best way to answer that. I don't know if Carla or one of the others, but for example, there are a couple of courses like an intro to programming class. You may take that in mechanical engineering, as well as you may take an intro to programming class in computer science. So some of those are pretty similar between all of them. So essentially all of the introductory courses are similar, and then the more advanced. So in the first 2 years, you take a lot of classes that are similar, and then in the second 2 years, they're very different.
Yeah, it really depends on the majors that you want to do, but Sarah's completely correct. You can definitely, your first 2 years overlap quite a bit, but if you're going to change between majors, like we suggested, your first year is your year of exploration. Take courses towards that major, like for example, the E001. It's a great class to take your first semester to explore electrical engineering. Mechanical engineering has some courses as well. So just kind of take those introductory courses and see what you want, what you're thinking about and what you're leaning more towards, and follow that.
Wonderful. And what languages would we code in when we're coding in electric and computer engineering?
So I think it's recommended we start with learning Python because it's a good computer language to get introduced into, but then electrical engineering tends to use more C or C++. I'm not a good one to answer a question about what you learn in computer science. I don't know if Professor Chen or Professor De Castro would want to answer that. There's so many languages out there right now.
Yeah, your answer, Sarah, is perfect. So usually when you go to computer engineering, you're going to code in high-level languages, Python, Java, and things like that. And then when you go into electrical engineering, you have the tendency to go into low-level languages with C, as Sarah mentioned, C++. And in some cases, if you are really interacting with the hardware, you might need to also code in assembly at some point.
Very good. Thank you both so much for that. And as I said, we are getting close to the end here. So I do have one last question before we start our wrap up tonight. What initially sparked your interest in electrical engineering? I'd like to ask our panel.
I started in 1979 and graduate school, and that was at a time of the oil crisis where people were lining up their vehicles and there wasn't enough gas because of the OPEC oil embargo. The countries that were pumping oil said, we're not going to pump enough oil. And then we couldn't, there were like some of the gas stations were only open half of the days or something because they ran out of oil. And so we said, what can we do to fix this problem? And there was a professor at the graduate school where I was who said, we can make solar cells and that will fix it. So I joined him and started working on making solar cells. And I've been working on solar ever since. That's back like in 1980.
Wonderful. Professor Chen?
Oh, I started 2 years later as an undergraduate student in 1981 in automation. So at that time, it is everybody's dream that in the future, a lot of things will be automated. But if you want to automate things, you want to make things under control. So actually, in the electrical engineering, there are multiple areas of emphasis. My emphasis was control system, to make things under control. So that triggered my career. So I'm a control guy, actually.
So in my case, I started a bit later. So in 2001, that's when I went to the university. And I went to electrical engineering because of two reasons. So the first reason was I really like circuits, I really like hardware. I really like to, before going to the university, I really like to disassemble some TV, some computer, and to understand how things working at the hardware level. So that was clearly for me that I have to go to electrical engineering to know more about how circuits operate. And then the second reason is related with a TV show that I used to watch in the 80s and early 90s. The show was MacGyver. I don't know if you know this show, but the main actor of that show, he used to build gadgets. And I realized, and I thought to myself, wow, it would be really cool if I could build this kind of gadgets. And electrical engineering is a path that enables me to do this kind of stuff.
Fascinating information. Thank you all so much. And I'd also like to offer this opportunity to Thomas. Would you like to share with us what initially sparked your interest in electrical engineering?
Working with Dr. Castro, actually. I was a student in his class and I'd show up to his office hours. I'm a computer science major. I still do want to work with computer science, but Dr. Castro has helped me realize that I would very much prefer to be doing something hands-on rather than just sitting in front of a desk bug fixing. If I could combine both of my interests, then I think that'd be something that'd be really great.
Wonderful responses from all of our panelists tonight. Thank you so much for that. As we start our wrap up, I would like to just share a couple of resources with all of you. And if you'd like to get your smartphone ready, you can go ahead and start just taking a screenshot of this or also just scanning those QR codes. Each of those will take you to a site with critical information. So if any of this has sparked interest in you this evening, this is the place to go. So go ahead and scan that first one. As it says there, each of them are labeled, but the first one there is for Discover the School of Engineering, and the next is for Electrical Engineering, and the last one is for the UC Merced catalog. So that is going to be jam-packed with everything that you could possibly have a question about regarding UC Merced, all of our programs, degrees, and any coursework that you may be wondering about in classes that we offer. I'd also like to give everyone a quick reminder that this tonight has been one of our Discover UC Merced virtual events. We have many more that have already happened, but also still upcoming in the next couple of months. So please take a look at that website so that you can get yourself registered for future online events. We also have in-person events coming up. And speaking of in-person, if you haven't yet visited the UC Merced campus, now is your great opportunity to take full advantage of that. We are offering campus tours 7 days a week. So there is no reason why you can't find a little bit of time in your schedule to make a trip to our campus and just take in all of its beauty and wonder. It is very high tech, as you've learned tonight, some of the fantastic projects that we're doing, and we are cutting edge with our technology. So please definitely take a look at that website as well. We will make sure we drop those into the chat before we wrap up here in just a moment, so that you could get yourself registered for a campus tour. We also have the virtual tours. On that website, you will also be finding some links directly to the replays of some events in case you happen to have missed a few of those. Lastly, we want to make sure that we leave you with our contact information. So if you have any additional questions that maybe we didn't get to tonight or something that is sparked later on, please feel free to use this information on your screen to go ahead and reach out to the admissions office. You'll see everything that's there. Grab your smartphone, go ahead and take a quick picture for reference later on at your fingertips. Also, you see our long list of social media platforms. A new addition is our TikTok channel. So if that interests you as well, we've just been recently dropping some more videos there. So take a look at all of those channels. You will want to follow all of those channels because we do give you critical information that's upcoming about new programs, new events, campus tours, all of the fun things that we have. And you also might see a contest or two where you can win some UC Merced swag. This has been a fantastic night tonight, everyone. We've had so much fun. We hope that you've been able to enjoy yourself tonight, get all of your important questions answered. We definitely hope to see you at a future event.